What's up, guys? If you didn't catch the last video, we hit 60 miles an hour with the 3D printed RC short course truck. Today, we're going to look at some experiments to redesign the parts that were failing most frequently. So let's get into it. So we failed the steering knuckles here 3 different times, same failure. So here we have a C-hub that connects to the caster block with these 2 screws, and then to steer the wheel, the C-hub, which is the broken part here, will turn right on the caster block, and these screws are put in with Loctite, and they're in there loose. The screw is actually acting as a shaft that turns around. So when this thing hit the tape measure, obviously all the force goes here. There's not much material that's going to stop this thing from coming off from hitting a tape measure. That's just the way it is. We might have been able to fix the first failure where it just kind of came down and hit the ground, and definitely the third one where it kind of just backed over a curb. Those are the 2 failures we're trying to make not happen again. The tape measure, that's probably going to happen every time, but I'm not going to worry about that. You can see the way it is failing. It's not necessarily the strength of material. It's failing in between the layers, which is a layer delamination. It's a common failure with 3D printed parts. It's what you got to look out for when you design them. But we want to see today if we can run an experiment on these 12 specimens. So what we're going to do, these are impact specimens. We're going to clamp each one of these in the vise here. And then we have this set up with a swinging hammer, and I have degrees marked, but that hammer will come down and hit the specimen. What we have is 3 different temperatures, 235, 245, and 255 degrees Celsius. And then we have 2 different materials. So this is the material that we've printed with mostly, the nylon turbine line, the nylon 6. And then the Tallman Bridge nylon 12. So again, 235, 245, and 255 degrees. So this will take care of one test, and then I have another set of specimens over here at the same time. We'll take care of another test. So the first set of specimens that we're going to test, we're going to start with it clamped in the vise. Pull it back 60 degrees. Let it go. Pull it back a little more, pull it back a little more. Figure out when it breaks. Record what that is. Hopefully we can capture with the camera how high this goes. I may be able to just see it myself, how high it goes. So the first test, we're just going to go through that. Now, if there is discrepancies, you know, say they don't all break at 30 degrees, and you know, some may break at 60, some may break all the way at 0. That's not necessarily a good way to compare, because when the hammer comes down, it's going to be going a different velocity when it hits. So the strain rate is going to be different. That's why I made another set of specimens that we're going to drop at a consistent mark. So for instance, if we drop this one at 20 degrees from horizontal, we're going to make that consistent for the entire set of specimens. So we'll run it through both ways, and we'll see what we have. All right, so this first test, I'm just swinging the hammer. We're going to see how high it goes, back calculate that energy out of the rest of the tests. So when we see how high it goes, we'll know how much energy was taken out of the material. All right, so here's test number 1. Bring it back to 60. Oh, right at 60 it broke. All right, so I had to run out yesterday, but here's the breakage from that first piece. Pretty clean, single layer separation. Let's load up the next piece. All right, 245 degrees, nylon 6. 60 degrees, actually let's start a little less. 60 degrees, here we go. Little crack there. So we just cracked it at 60 degrees. You can see it separating. It's not separating at the fillet like it did the last time. It is sort of a single layer. All right, since that last one just broke at 60, I'm gonna keep it all the same for now. Start with 60. Again, 255. 60 did not break it. I'm gonna draw some more lines on this board. All right, this is 255 degrees, nylon 6. We're gonna pull it back to 50 degrees. And we cracked. This time, cracked in the vise, halfway down. And the interesting part is, it's not a interlayer bond failure. You can see it breaks through multiple layers as you pull it back. All right, we're gonna go nylon 12, Tallman bridge, 235 degrees. Okay, we're pulling back to 60. Okay, no break. We're going back to 50 degrees. Nothing. Okay, 40 degrees. Nothing. 30. Nothing. 20. Nothing. 10. Nothing. And finally, 0. And we get a break. That's the failure we got. 235 degrees, Tallman bridge, nylon 12. All right, I found the other piece, so check that out. No interlayer bond strength problem there. Let's go to 245. Now, that failure was at 235 degrees. We had no problem with interlayer bond strength. So raising the temperature to 245 and 255 really may not show us much. But we're gonna just go through it as we work. So 60, 50, 40, 30, 20. Okay, I broke at 20. We just cracked it. Same kind of failure there. All right, 255, 60, 50. Yep, bad hit there. 50, 40, 30. Okay, we got a crack at 30. So, again, there we go. There's no interlayer separation. So that completes the first test. Next test is going to be at the same drop angle, and we're going to see how high it goes. So we're going to be consistent with our strain rate, and we'll run through all the tests one more time and see what the impact strength is. Since the most energy we got out of the other specimens was a drop at 0 degrees, we're just going to drop it right from there, from each time. There we go, 235 degrees, nylon 6, drop from 0 degrees. It went up to about 50. We'll play that and look at it. There's the failure at 235 degrees. Mostly interlayer separation. There's, if you look here in the middle, most of that's just delamination. All right, 245 degrees, drop from 0. All right, 245 degrees, there's your failure. Some layer separation up here. We're starting to get into more non-layer separation type failure. Okay, here goes 255 degrees, nylon 6, drop from 0 degrees. All right, that one up a little bit higher than the first one. All these failures seem brittle. I'm gonna have to go digging for the other piece, but there's that. You can see there's still some layer separation up on this side, on this face, but then as you work your way down, most of the part is non-layer separation type failure. All right, I can't find the piece. I looked around for like 5 minutes. Again, there's a failure. 235 degrees, nylon 12, drop from 0. Woo! It's like we cracked it. We're not going to get a number there. There's a crack. Interesting how it's cracking in the vise and not up top where the area is less. I'm going to do this test one more time. We'll just have to take note of it. I'm going to clamp it a little bit harder, try to grab that top surface. Nice a little bit more. I don't want to clamp it too much, then we'll be putting stress in the areas, that stress may propagate in the areas that we don't want it. But as long as we're consistent, I think we'll be okay. Let's see if this will break. Once again, 235 degrees, nylon 12, drop from 0. Still the same result. I'm going to turn it around so that it's not breaking this way, but this way. 235 degrees, trial number 3, drop from 0 degrees. Okay, we finally got it. But honestly, it literally just cracked in the same spot that it was already starting to crack at. So there's your failure. Here we go, 245 degrees, nylon 12, drop from 0 degrees. Right on. And there's the other side of that. Don't know how well it's focusing. But what we can say is, for the most part, there's no layer delamination, no layer separation failure. Last test, nylon 12, 255 degrees. And that's it. Here we go, last test, nylon 12, 255 degrees, drop from 0. Alright, we'll see how that went. Okay, same failure as 245, almost identical to 245. Alright guys, I had to cut this video short. Take a look at part 2, we'll go through the results.